I'd like to do another example. So in this example, we're discussing the set of all multiples of 3. So we have 0, 3, 6, 9, 12, 15, and so on in the positive direction, and also the negative multiples. -3, -6, -9, -12, -15, on and on and on in the negative direction. The set can be summarized in builder notation by taking any integer and multiplying it by 3. That's what we mean by saying multiples of 3. So is this set closed under addition? Let's try to add some numbers within the set. 3 plus 3 gives us 6. 3 plus 9 gives us 12. -3 plus 3 gives us 0. -3 plus 9 gives us 6. All of these examples that I can come up with land me back inside of the set. Let's try to take two numbers within this set, add them together, and show that we always land back within the set. So digging my hand in the set, I'll pull out a 3a and a 3b. Okay, so with the 3a, I want to add it to 3b. And we notice we can factor out a 3, and we get a plus b in the brackets. So a plus b represents an integer. These numbers here are one of the integers. If we take an integer, this thing, and multiply it by 3, we get another multiple of 3. So indeed, we ended up back in our set M. So the answer is yes. What about subtraction? Again, you can take some examples with subtraction. 6 minus 3 is 3. 9 minus a -3 is positive 12. These examples seem to give us another number that's back in the set. Let's try a very similar idea. Take 3a and subtract from 3b and see what happens. Again, you can factor out the 3. Now, a minus b is again an integer. You take two integers and you subtract them, you get another integer. When you take that integer and you multiply by 3, you will get a multiple of 3. And that is exactly what's in our set, all the multiples of 3. So we can say yes, we are closed under subtraction. Are we closed under multiplication? Let's try some examples. 3 times 3 is 9. 3 times 9 is 27. -3 times -6 is positive 18. All of these seem like multiples of 3. Let's try a proof. Let's try to prove that when you take a random number within the set called 3a and another random number within the set called 3b, you get a result that's back within our set. So the question is, can we write this as 3 multiplied by some integer to give us a multiple of 3? So we want whatever we put inside of this bracket to be an integer. Now, what we can do is use our associative property and commutative property to rewrite the expression that we've just written down to write 1 3 on the outside of the big brackets, 1 3 on the inside, and the a and the b are still on the inside of those brackets. 3 times a times b is indeed an integer when a and b are integers. So this does land us in our set of multiples of 3. Now, finally, with division, if we have two numbers that are integers, we may not make another integer if we divide them. We might not make that integer. So you could do something like 3 divided by 9. Those are two numbers from our set. Those are two multiples of 3. But 1/3 is the result of that, and you don't get a multiple of 3 out of that deal. So this is not within our set M. We found a counterexample, so we can say the answer is no.